start with some introductions. I am Claudia Ruiz-Graham. I'm the founder of Image Reality and CEO, geologist by background. Most of my experience had been in exploration and appraisal. We are Image Reality. We are a UK company, technology company, the developers of Stratbox. Stratbox is a platform that aims to help multidisciplinary teams reduce subsurface uncertainty through data integration and team collaboration around digital twins. Today, we're going to see a case study of data integration and reservoir analysis in the Volve Field. And I'm very happy to be joined today by my colleague, Ailen Broya. She's Argentinian. She's a sedimentologist with over 10 years of experience from La Universidad de La Plata, also data scientist. Ailen, welcome.
Thank you, Claudia, for the introduction.
Thank you very much for joining us today. So, Ailen, before we start, tell the audience what we're going to be covering today. We are going to be describing the reservoir characteristics in the reservoir of the Volve Field using two wells from this well, and we're going to be doing this in the Stratbox Core Explorer platform. Now, I'd like to start asking you a couple of questions, Ailen. What is your normal workflow when working with core data?
Yes, first I carry on lithological description, where I integrate core image description with gamma ray responses. Then this output I integrate with sedimentary structure interpretation and thin section description to achieve phases definition. And then I correlate the phases with their porosity and permeability value to achieve reservoir zonation and quality assessment.
And in your experience, what do you think are the key challenges that you have experience using core data or working with core data?
In my experience, the main challenge working with core data was to try to analyze and integrate all the core data, because I used to have all this data scattered in different apps, in different databases. So this integration, it's work-consuming integration, time-consuming integration, non-efficient, non-optimized. Also, another issue that I have is that I used to have a limited access to core store, to the core data information. What about you, Claudia? What was your experience with core data in your previous work?
So actually, I can share some info from feedback we received from customers. We have some customers who have very large core stores. The teams in these companies, in some of these companies, might have to wait up to 6 months to get access to the core store, to see the physical core. That's one thing. In the other hand, a company might have a lot of digital data on the cores, but the data seems to be scattered. Some data, for example, stored in the petrophysical software. Other data might be like separate in images on the servers, and so on and so forth. So quite a lot of data silos. So that was one of the key reasons why we got working on developing Stratbox Core Explorer. We did this project sort of working closely with Shell. But now I would like to enter and maybe share my screen right now. We can enter now into the discussion of the geology of the. So what are we seeing here? We are seeing here two wells. Imagine these as digital core tables. So we have two Volve wells, the well 19A and the BT2. This Volve field is located in the central North Sea, in the Norwegian side of the central North Sea. We go back to the catalog of the well. What I can show you here is kind of some general information of the field. It's to the north of it's located to the north of the Sleipner field in the Norwegian side. And the trap is mostly, well, it's an extensional tectonics of the Jurassic rifting system. You can see here the location of the two wells. This field, the main reservoir, is Middle Jurassic. It corresponds to shallow marine sandstones, shallow marine to tidal sandstones during the Middle Jurassic. This field, the original resource estimation was 75 million barrels, and that producing about 67 million barrels or something like that. Well, Ailen, and in a collaboration session right now, I can see you have joined. But, what we're gonna do is go together through some observations on the core images. So I'm gonna bring the first image that we see here. Let me just do this. So in terms of the observations, my observations, I can see here, let me just do this, like sort of a burrow, presence of a burrows in this sector. Maybe Ailen, could you help us describe what we are seeing here?
Yes, I agree with your interpretation. I also see these mud traps, these common mud traps. Sometimes there are bioturbated. I also see this cross-bedding sedimentary structure. Also, if we focus on that, I also see this bedding, the mud traps that I mark with this arrow.
And now if we look at one of the scene sections located just at this, that was taken just at the core block over here, we see a beautiful, or I would say beautiful because of the amount of porosity and connected pore space, sandstone quality, with porosities of nearly 17% and nearly 1 darcy of permeability. So if we sort of now navigate towards the middle section, let me get the right tool here. Let me navigate towards the middle section. We can compare a little bit on the differences. Yes. And maybe Ailen, if you can sort of help us with the description here.
Yes. I'm seeing sandstone, planar parallel sandstone. This is the planar parallel that I described. Sometimes it contains these mud traps or very thin laminae of mud that I mark with this arrow. This is a very sharp contact between this laminated sandstone with this massive sandstone. Yes, this massive sandstone is partially stained with hydrocarbon.
Good. And if we look at the scene section, still looking some good porosity, but I guess we start seeing the intercalation of these, I guess, organic matter.
Yes.
On these scene laminations, right?
Yes.
So but now, and if you look at the images here, they're showing quite a lot of the stain, but then on here they look different. So if I bring one of these images, what this is showing us now is a change on the reservoir, and yes, these are more cemented sands.
Yes.
What can you tell us about the observation on here?
Yes, this is a calcareous sandstone where the thin section fill all the poral network of this. If you open the thin section, you can see the calcite cement that fill all the pore space.
Okay, so that gives us an idea of the variability in the reservoir from some excellent sandstones to some tight sandstones. If I go back here, we go through the middle of the section, and basically the whole, like if I bring this oil sample, this oil image on here, completely stained, hardly we can see any sedimentary structure. But if we look at the porosity and permeability, just fantastic, right? So it's just a super quality on here. So as we move in general, we might see another area of cemented zone, and then we go again into very good quality reservoir, mostly stained, but you can see that the entire well is completely stained except for certain areas where you get variability in the reservoir. I'm gonna leave the collaboration session now, and let me just go back to this. Now, just to show you, in addition to the core table, we have on here the log panel, and that basically contemplates the interpretation that Ailen will be discussing with us in terms of the zonation of the reservoir and lithology interpretation. Maybe if you can start sharing your screen.
Let me just maybe I can start with your screen, if you.
Or Viviana, if you could please share Ailen's screen. Okay, or maybe let's go back to my screen here. Okay, you got it now.
Give me
All right. So what I will do is just show you in the meantime what we have in the tracks in the core Explorer here. We got the stratigraphic tops. We have the gamma rate with a cutoff that has been applied to differentiate those areas, those lithologies that are sandy versus shelly lithologies. The lithology column that has been built based on the observations on the images, plus the description of the lithology on the logs. This corresponds to hotspots that are basically, they load automatically at the right depths, and it's the points that you see here over the images. The next track corresponds to the interpreted phases, and as you will see, we will see the overlay of those phases over the core images. Let me just close that. The next track corresponds to the porosity, permeability. This one is porosity and grain density. Here, a mineralogy track. And then here we have the oil saturation in green, the water saturation in blue, and as you can see, the entire core data was in the oil section, as we saw during the images as well, with the impregnation on the entirety of the core. You want to share your screen now?
Yes.
Okay.
Thank you. After the observation of Claudia about the lithological description of both wells, I'm going to start to talk about how many meters it drilled in each well. In the 19A well, it drilled 63 meters of this unit. If we focus on the gamma ray log, we can see color in yellow, the different sandstone body Claudia mentioned to us. If we move to the BT2 well, we can see in this case it drilled 72 meters of cores. If we focus on the gamma ray log, we can see the same behavior as 19A well. Claudia mentioned before in this well, the sedimentary structures and the lithological changes are more visible if we compare with the 19A well. So for that reason, we decided to carry on image analysis by random forest indicator. The output of this image analysis is the following that I show you in this part, in the lower part. Let me put in the same grades. Okay. If we compare the output of the core, the image analysis, we can see in purple color the lithological class stained sands that match in 90% with all the stained oil sandstone of the BT2 well. But if we move to the yellow class that correspond to bioturbated sandstone, we can see that the algorithm not just identified all the interval that is fully bioturbated, it also identified the interval that are present isolated bioturbated sandstone in this case. Let me show you the match between the image classification and the core image. So this was preliminary lithological analysis that helped me to carry on then with the gamma ray responses, helped me to draw this lithological description. So once we describe the lithological changes in each well, we move to the phases classification for each well. We're going to start with the BT2 well. Let me show this bar chart. This is the bar chart that represents the facies thickness distribution. We can see that for the Volve BT2 well, the thickest facies are tidal channel, tidal bar, mode bar. Let me show you an example of that. And first, we're going to see the distribution of faces. This is the faces log. I'm going to overlap the faces on core images. Right. Yes. And let me show you an example of each face. For example, a typical example of tidal bar faces correspond to this fine to medium grain sandstone with this low angle cross bedding. Another beautiful example of tidal channel faces correspond to this medium to coarse grain sandstone with planar cross bedding that partially stained with oil. The last example of moldar faces correspond to this, that is a fine grain sandstone with this planar cross bedding with this common matrix marked by this arrow. The typical interval fully or partially deoturated. If we move to the 19A well, we can see, let me show you the bar chart with the faces distribution. We can see that the thickest faces on this well correspond to the tidal channel faces, mold bar, and tidal bar. We can see how they look like, and also I'm going to overlay the faces on the well. Great. I'm going to close this. This is a typical example of mold bar faces in this well. This corresponds to the fine grain sandstone, massive to diffuse low angle cross bedding. Another example of the tidal channel faces correspond to this sandstone that is fully stained with hydrocarbon. It's a medium to coarse grain sandstone with cross-bedding, planar cross-bedding, and if we compare the behavior of the appearance of the tidal channel faces of BT2 well, we can see that in the case of 19A well, these faces is affected by the oil impregnation that mask the sedimentary structure, the grain size changes. So the last example corresponds to the tidal channel, the tidal bar faces. You can see these that correspond to a fine to medium grain sandstone with this planar cross bedding, and it's partially to fully stained with oil. So now we're going to correlate the faces with their porosity and permeability value. In this case, the porosity log is colored with blue. The permeability is colored with red. For this study, cutoff value for porosity about 50%. For permeability, cutoff about 100 milliliters. So this allows me to differentiate 3 zones of interest for this well, for the 19A well. Let me show you the extension of this zone of interest. Yes, great. From bottom to top, we have the lower zone of interest that corresponds to this zone between these green to light blue lines. The medium zone that corresponds to the zone between the pink ones. The upper zone that corresponds to the zone between these light blue lines. If we focus on the porosity and permeability log, we can see that in all the zones, the zone shows porosity greater than porosity cutoff value. But if we focus on permeability log, we can see that just the medium zone shows permeability greater than permeability cutoff value. In this case, the permeability reached values about 20,000 milliliters. Let me show you an example of this medium zone of interest. I forgot to mention that for that reason, this zone of interest is the zone with the best reservoir quality in the 19A well. Let me show you an example of this zone of interest. We can see that this example is fully stained with hydrocarbon, and if we open the thin section that is associated with these faces, we can see with this purple arrow that mark the pores in this thin section, both pores. The yellow arrow that mark the poral trough that connect the pore to each other. So in this case, we can see color with blue, the excellent porosity and excellent permeability of these phases. If we focus on the permeability and porosity value, we can see that the permeability reached 11,000 millidarcy, and porosity reached at 24%. If we move to the BT2 well, we can see that in this case, we differentiate two zones of interest. Let me show you, and let me show you their extension rates. In this case, we differentiate the lower zone of interest that is between this green to light blue zone, the upper zone of interest that is between the pink one. If we focus on the porosity and permeability log, we can see that in both cases, the porosity and permeability are greater than the porosity and permeability. So, but if we focus on the permeability log, we can see that just only the lower zone shows the greater permeability value that reaches 7,000 millidars. So for that reason, this zone is the zone with the best reservoir quality in the BT2 well. Let me show you an example of this zone of interest. This zone is composed mostly by tidal channel phases. So I'm going to see a typical example of that. This is a typical example of these tidal channel phases that are partially stained with hydrocarbon. If we open the thin section associated with that, we can see the excellent porosity and permeability value that shows not just only the intergranular pores, but also the intergranular pores that are connected to each other. So now we differentiate the zone of interest. Now we are going to create different charts to show this how the porosity and permeability value correlate with the phases in the different zone of interest. So now Claudia is going to show how to create the different type of chart on Core Explorer.
Thank you, Ailen. I'm going to share my screen now. So what I'm going to show you is like a pre-release feature of the Core Explorer. We will be releasing this within probably in about 4 weeks' time. And our aim is to help with a great data integration and interactivity so that users can easily check the ground truth. So in this case, we have implemented this charts feature or in the Core Explorer. For this well, I'm gonna plot the, let's say, permeability versus, let me just go this one over here. I'm gonna plot depth versus permeability, right? So let me just do this again. So I'm gonna put it on the right axis. Sorry, just give me a sec. If I take the depth versus porosity, let's say I'm using the wrong field. Apologies, I'm using the wrong field on here. I'm gonna use porosity on this axis and depth on this axis. And now I'm going to color code this by phases, right? So in this plot, we can see that it's consistent with what Ailen was showing. Like in yellow color, we have those phases, which are the tidal channel, which has the best, in this case, porosity. But also in the shallowest part, we also have a section with tidal phases, but has low porosity. So let's come and check what's the difference. I'm gonna click on this point. It opens the actual image automatically, right? I don't have a thin. This image doesn't have a thin section, but it has the core block, and as you can see, porosity is really great on here, 25%. Now let's compare it with the area where we have poor porosity. Let me see if that open that one. Let me close this, open one of these ones. In this case, the porosity is only 12%. This thin section corresponds to that plot and corresponds to the point that I selected here. So it's the kind of interaction that we are integrating into the Core Explorer. So if you need to check data points, you can easily go back to your rock and your source of truth. I like to, for the time being, to stop here, and then maybe Ailen, if you want to share sort of the key conclusions of your observations.
Yes, sure. Yes, the key conclusion for this reservoir analysis workflow that I carry on Volve Field are: first, by the multi-scale reservoir analysis, I can differentiate 3 zones of interest on Volve 19A well, 2 zones of interest on Volve 2 well, and also it allowed me to differentiate different heterogeneities in different scales, from the reservoir scale to the pore scale. And what I mean is it allowed me to differentiate this in the core images, log, gamma ray log, also in the thin section description. Also, this integration that I carry on in Core Explorer allow me to optimize, reduce my integration, my traditional workflow for reservoir characterization. It reduced my time, working time, and also it optimized my work.
Okay,
thank you, Ailen. Ailen, on that point, are you able to give us an idea of how much time you saved by changing your workflow, just using one specific piece of software, in this case, Stratbox Core Explorer? Can you give us an idea?
If I think in this reservoir analysis workflow that I carry on, I think with this integration, I reduce between 40 to 60% my time in my workflow.
And in terms of days, what would you say that equates to? I mean, how long did you spend on the project itself?
I spent three days in all the project to upload the data, to integrate all the information, and make some conclusion about that. It reduced 1 day of work in these 3 days.
So quite significant then. Thank you. Okay, thank you. We have got a question actually here from the participants. Viviana, thank you. So this is from Ailen, and she's saying, how would you explain the preservation of so high porosity and permeability in the Hugin, I'm not sure how to pronounce that, sandstone that is presently buried to about 3.8 to 4 kilometers of depth?
I think that this porosity and permeability value are preserved. This high porosity and permeability value were preserved because most of, especially the tidal channel faces, are cemented or fixed by this carbon content. What I mean is the oil behave as a cement in this type of phases. And also I think that most of especially the greater porosity and permeability value, I don't know how you say in English, are higher than the real values. I mean, I don't know how you say it in English.
You say it in Spanish, Ailen.
Están expandidas.
Overestimated, you mean?
Overestimated. Thank you. Thank you.
Also, there also could be that from early diagenesis help to preserve the porosity. For that, we don't know, but it could be a possibility.
Okay. We have had another question that I'd like to ask. Up to how many wells can be compared at any one time with the software? In this case, you had 2, and you had the third well, which was really the machine learning images. But up to how many have you had experience of using?
Maybe Claudia.
I can speak of our customers. They have created projects of about maybe 5 wells or something like that, but with a lot of data. So managing projects individual projects in the order of gigabytes of data. One project has close to 3 gigabytes of data, for example.
Okay, thank you. So we have another comment here and question: at what stage of an exploration or reservoir development project does Stratbox Core Explorer deliver the most value? And how does it support specific workflows of a sedimentologist, petrophysicist, or reservoir engineer?
I think the Core Explorer delivers value at the stage of development, particularly when petrophysicists are calibrating their data and they need to go back and check the samples with the ground truth. So having a platform where the data is fully integrated, would be easier for them to check that. Or also down the line where wells are drilled and surprises are being found. Again, going back to the ground truth. In exploration, it also has value. I would say when I work exploration in the past, and we were building GDs, gross depositional environments, and we collected historical information. And we had appraisal wells with core information. The core reports, the information about core data was dispersed around core reports. Images were separate. Sometimes you might not even find the information that appeared reported. So having a catalog of your key wells, like a virtual library, this is another example where it adds exploration in development. So in exploration, so across the let's say the exploration development cycle. But I think the way we have where we see is really helping the sedimentologists and petrophysicists and reservoir engineers working with an integrated data set where they can easily go back to the ground truth.
Thank you, Claudia. I also wanted to ask you, could you expand a little bit on the use cases of Core Explorer? Obviously, it's being used in workflows. Are there other cases? Is it workshops? How else could it be used, and is it being used currently?
So in terms, thank you, Eduardo, for that question. I guess you referred to the previous question, the value of the Core Explorer. So in terms of the other use cases, again, I'm just referring from customers as well, using the workflow as a digital twin of core stores, or using it in collaboration sessions as workshops with multidisciplinary teams.
And also it could be used also for peer reviews, I guess, right? As a way of demonstrating the data set to management level to have a clear picture of everything, right?
Absolutely.
Thank you. Okay. I think I've seen. What plans are there with regard to AI for Core Explorer? Currently, we're using AI with Python, but could you give a little bit more detail on that, perhaps?
So Stratbox Core Explorer has a Python API. The Python API enables you to export your data from Core Explorer into the Python environment and then run your own ML models. What we have done here in the example that Ailen showed, the team built training the data set using a random forest algorithm and achieve this lithology prediction. The plan is to use more advanced algorithms, such as CNNs, and that could help with a better prediction. But in terms of our roadmap, what we are excited about will be as well with a plan to integrate in the Core Explorer cluster analysis to enable use a first look of rock typing, for example. And also we have in our plans to incorporate Gen AI and like that with a view to enable companies who already might have the internal version of, let's say, ChatGPT or Copilot, wherever they're handling their data set, having a connector to this kind of platforms to enable users. I can easily imagine a team working in, for example, this type of reservoir and finding certain surprises and being able to question the data set and say, okay, show me the other wells that show this type of characteristics and give me a summary of that. So it's really exciting because it's going to help geologists, petrophysicists, and engineers to get faster to the answer.
Thank you. And I guess by doing that, Claudia, those smart searches that could even then populate your satellite imagery to show you exactly where those wells are located, right?
That's one way that is currently as well being used in the industry.
Perfect. Thank you. Another question for you. Can Stratbox Core Explorer be adapted to support lithological and structural interpretations in mining exploration, especially in integration of drill core imagery, geochemical essays, and geotechnical logs within a single work?
Well, in mining, definitely. Mining uses similar type of images and similar type of information. So yes, it definitely has a use case in and a great potential for the mining area.
Excellent. Okay, wonderful.
Okay, thank you, Ailen. And I'd like to invite our listeners, if you are interested, here are our contact details. If you like to have a trial of Stratbox Core Explorer, that we can arrange this. But I like to use maybe the last couple of minutes to show you like a 3D model of this type of reservoir. I can, Vivi, if you can sort of break my screen. Thank you. So what we see here is one of our other applications, Stratbox Connect, that basically has access to a catalog. In this case, it's the RPS catalog of group analogs across different environments, continental classic, deep water classic, but we're going to have a look at this beautiful example of heterolytic cross-bedding in tidal sandstones. This is a model from a 3D outcrop model. I think this one is from Spain. It's quite a small outcrop, maybe 3 to 4 meters. But you can see it's a really nice, super quality of this stratification. Now, I just wanted to show you one of these beautiful examples of what reservoir in subsurface might look like. Very good. Finally, just a huge thank you to Ailen for the collaboration in this project. And just to invite anybody just to follow up with questions, and to the audience, thank you very much for joining us today. You saw our contact details on the last page. Thank you very much. Thank you, Gabriela and Viviana, for helping us with the webinar today.
You're welcome. Thank you, everybody. Have a great day.
Thank you.
Thank you.